Okay, so real quick, because I noticed that I just messed up and didn't record like I was supposed to. Okay, so our question prior was over the 7th term, so this being 1, 2, 3, 4, 5, 6, 7. Even so, though it says 3 to the 6th power, they started with a 0, and so that's why this is the 7th term, and they asked what is the ones place. Well, the ones place value is the number 9, and if you saw the answer choices, which you can always go back on your quiz, you will see that number 9 is in the ones place. Now we were talking about reflexive property, which I can't, or reflexive, symmetric, and transitive. I can't move back in the quiz right now. Again, I thought I was multiplying and I wasn't. I mean, recording and I wasn't. But so it was asking if the measure of ABC is equal to DEF, and if DEF equals ABC, what would the property be? When you see numbers being reflected back like that, like x equals y, so therefore y equals x. Well, the measure of ABC equals DEF, then DEF equals ABC. So that was the symmetric property. So we're going to move on, though, to question 7, which says, which diagram shows the construction of an angle bisector? Okay, I need y'all to know what an angle bisector is because, again, we haven't reached that. We're not there yet, but we still have to take this test. So here we have the blue angle is being bisected by the red bisector here. Okay, so let's go back and look. A, you do not see it being bisected. B, nothing's being cut in half. A bisector cuts in half. C, this is an angle, but there's nothing coming in between it as such as a bisector. And then we have the letter D, where the original angle is here and the bisector is coming through. And then they show the point here and then a piece of the angle measurement. So D would be where the angle bisector is. And if you needed to look up, okay, angle bisector, they give you a few examples at Math is Fun, which I love Math is Fun website. So I'm always going to be a proponent of that. The next thing here, it says, which of the following correctly names the plane below? Now listen, we talked about lines, segments, rays, and points, but we did not talk about naming of planes. So we're going to go ahead and talk about that. So here, how to name a plane in geometry. Okay, so let's go and kind of explore that a little bit. So I love this. I love it when they keep it simple. It's kind of like a one-pager. Ugh, they're going to make me look for this. Okay, we're just going to use the image. So it says planes are named using 3 points on a plane or a cursive capital letter. So we're going to look for some points on the plane here in a minute. And we're going to look for the capital or the single cursive uppercase letter. So let's go back and look at that. I do have the cursive letter B, but I don't see that as an option. I will not be using the letter B in anything there, so I'm going to go ahead and tell you that B can't be the answer. But what we can do is find 3 points on here on the plane. That means inside of it somewhere that could work. So we know that R cannot work because it's not on the plane. Does that make sense? I hope it does. So that would get rid of D, and of course I told you B can't be it. So we've got GTM or TMA. And those are options right there. Which of the following correctly names the plane below? Now, GTM, I'd love to say that that would be an excellent answer choice, but those are all falling on a line, and those are points on the line. Yes, they're within the plane, but we're looking for the points in and around the plane, not just on the line. So to have T, M, and A, they're all inside. And A, it stands alone over here, but it's still part of the plane. And a plane is just a flat, solid surface. So to which lines and segments can go through and raise. So C, being TMA, would probably be your best answer choice. Moving on now. Question number 9. If 2 angles are adjacent, then, well, you guys need to know what an adjacent angle is. So we go over adjacent angles. We want their definition, of course. So let's talk about them. Okay. So it says, if I can find my definition, because I would rather do that. There we go. Again, it takes me to Math is Fun. I love Math is Fun. Okay, so two angles that have a common side and a common vertex or a corner point, and they don't overlap. We see here this one is not overlapping, this one's not overlapping. Here's the shared vertex, this is common, and they have a common side, which is this right here. So what are some true things about adjacent angles? Well, let's go look at them. They are always supplementary. Well, no, what we just saw right there, supplementary means 180, and these two angles do not measure 180. 180 is a straight line. So they're not always going to be. Now they can be. So it can't be A. They're always complementary. No, they can be supplementary. That just has to be wider angles that we saw just then. They share common internal points. I didn't see any points there, but here's something right here. They share a common vertex and side, and that is true. So it would be the letter D. Okay, we're getting close to the end. Question 10. What is the converse to the statement? Okay. Converse, so I did not go over with you conditionals, which are types of statements to say. And I'll be honest, I did that on purpose because those are incredibly difficult to decipher through and they take up a lot of time and we're already so far behind. So looking at a statement, so say a teacher says, if the number is divisible by 2, then it's an even number, which that is a true statement. The converse of it is if it is an even number, then it is divisible by 2. They took the sentence and they flipped it. So they said the first thing is true, which makes the second thing true. So converse means just taking those two sentences apart, or taking the one sentence apart in two pieces and switching them. So coming over here and it asks which one is converse. If it is not raining, then it is not cloudy outside. Oh, let's look at our first statement. If it is raining, then it is cloudy outside. Okay, we want it to read, it is cloudy outside. If it's cloudy outside, then it is raining, which we know that's not true, but that's still the converse. So if it's cloudy outside, then it is raining. There we go. And then these others are, like these are inverses. So B would be your answer for that one. Okay. Question 11, we're nearing the end. If point B is the midpoint of AC, point A is located at 3, 7, and point C is located at 3, -1. Find the coordinate for point B. Okay, we need the midpoint formula. And so let me clear this off. Let's get that midpoint formula first, okay? So midpoint formula. We're going to go back to Math is Fun. Again, I just love it so much. Okay, so they're telling us the midpoint of a line segment. It's YA plus YB divided by 2, and then XA plus XB divided by 2. So come over here. Y, you can put YA or you can put Y1. Y1 plus Y2. And when you do that, and then you divide by 2, you'll get the midpoint. And then X1 plus X2, divide that by 2, and you'll get the midpoint. So let's go back over to the equation. They tell me point A is 3, 7, point C is 3, -1. So I have 3, 7, and 3, -1. And I have to determine which is going to be my 1 and which one's going to be my 2. I'm going to make this one my 1s, and this one's going to be my 2s. You could have flipped it and you'd still get the same answer. Okay, so I'm going to take my Y because these are my X's right here, and these are my Y's. Okay, I'm going to add these together. So 7 plus -1. Divided by 2. You can do it on the calculator. You can do it just using your mental math. But 7 plus a -1 is actually just going to get me a 6. And then I got to divide that by 2, and I get 3. So not done. Now I got to solve this over here. Okay. So I look at my x's, and it's 3 plus 3. It's going to be over 2, so 6, because 3 plus 3 is 6, divided by 2, and I get 3. So my midpoint will be 3, 3. And looking at my answer choices, that would be answer B. Okay, I only have a few more minutes left on my recording, so I want to make sure I help you guys out. This very last one, it says use the diagram to complete the proof. Now again, I have not taught you proofs. I also did not teach you inverse and converse statements yet. And proofs we're really not going to stress too much about. I want you guys to try your very best. They give you all of this right here, and they want to know what's missing right here. It says BCE, so B to C to E equals ACD. Okay, well, those right there, they want to know, is that vertical angle theorem? Is that linear postulate? Is that subtraction property or substitution? I'm going to go ahead and tell you right now, it is not C or D. We're not focusing on properties there. We're looking at theorems and postulates. So let's go look real quick at what a vertical angle theorem is. So you know, I need you to see that. Okay, so this is a vertical angle theorem. It's saying this and this equal each other. Going back to that, BCE and ACD equal each other. That is vertical angle theorem. We don't even need to look up linear pair postulate. We know vertical angle theorem is correct. So you can choose A on that one. And then at the end, I need to remind you to please submit your quiz. All right, that is the end. I appreciate you guys and thank you.